Hello friends, welcome to video series on geography. In my previous video I explained about adiabatic lap state and latent heat of condensation. In today's video I'll be explaining about pressure belts and permanent winds. Pressure systems, ocean currents and wind systems have a great influence on temperature distribution on Earth, and all these factors are interconnected. Hence these factors greatly influence the climatic factors at various parts of the Earth. Hence it is important for us to understand these major phenomena which influences temperature distribution on Earth. The first ones are pressure systems. In pressure systems, we'll study about permanent winds as well because these two things are interconnected, so we'll be studying them together. There are total 7 pressure belts, 1 equatorial low, 2 subtropical highs, and then we have 2 subpolar lows, and then we have 2 polar highs. So what we see, these are the polar highs at both the poles, and then we have 2 subpolar low pressure belts, one in the northern hemisphere and the other one in southern hemisphere. Likewise, we have 2 subtropical high pressure belts, and at the equator we have equatorial low pressure belts. So while studying these belts, we'll consider certain cases. So we'll be taking only some ideal situations instead of considering a lot of factors. So we'll consider that both northern hemisphere and southern hemisphere has the same kind of landmass and oceans. That is, there is no differences in the area of land masses present into both the hemispheres. And then we'll also take into consideration that various factors that influence climates are same for both northern hemisphere and southern hemisphere. That is, there is no difference between various physical features. So under such a condition, this is the way we see the pressure belt system and wind system. And also we'll consider that there is no apparent shift of sun from season to season. So let us take that the apparent movement of the sun is only along the equator. It doesn't shift from Tropic of Cancer to Tropic of Capricorn. So in such a case, this is how ideally it looks, both the pressure belts and the following winds. So what are the factors that control pressure systems? There are 2 factors. One is thermal factors, other one is dynamic factors. Thermal factors are nothing but variation in temperature. The differences in temperature between equator and poles give rise to certain pressure belts. These pressure belts are called as equatorial low, which is formed due to greater temperatures at the equator. And then there are polar highs. These pressure belts in both southern and northern hemisphere, that is at the south pole and north pole, are formed mainly due to a very cold climates, that is due to less temperature. So these 2 pressure belts depend on temperature, hence they are the result of thermal factors. And then we have dynamic factors like pressure difference or pressure gradient force, and then we have Coriolis force, which is very important. Coriolis force is nothing but an apparent force which is a consequence of rotation of Earth. So we'll see about Coriolis force in future slides. So the pressure belts like subtropical high and subpolar low are the ones which are created due to dynamic forces. So we'll see them in detail, only then we'll understand these things. First, let us look at basic concepts. Let us study the movement of air. There are 2 kinds of movements. One is vertical movement, other one is horizontal movement. Vertical movement is also called as convectional movement. I've explained before what is convection. And the horizontal movement is called as advectional movement. So there are 2 kinds of vertical movements. One is called as upliftment, when a parcel of air is uplifted from its original position. And then we have subsidence, where a parcel of air drops to the surface when its weight increases when it's in the top levels of atmosphere. So what happens in upliftment? When a parcel of air is heated, it becomes low in pressure compared to the surrounding areas. As a result, it is pushed upwards, and the parcel of air moves upwards. I've given a detailed explanation in adiabatic lap state how a parcel of air moves upwards. So please watch that video. You'll understand how a parcel of air moves towards the upper levels of atmosphere. So this upper level of movement of a parcel of air is associated with a vacuum-like situation at the bottom, that is at the ground level. And this vacuum-like situation is nullified or filled by the winds that are rushing from the surrounding areas. We can see these winds are rushing from surrounding areas towards this region. So this region is also called as a low pressure system or a low pressure center. This is because there is upliftment, there is negative pressure which is created at this region, hence it is a low pressure center, and all the wind from the surrounding regions gushes into this region, and the wind doesn't come in straight paths, but there is certain deflections. So this deflections of wind is mainly due to Coriolis force, and this deflection of winds creates a circular system of low pressure where the winds create a rotating or swirling motion of wind, and this column of wind which is swirling is the wind that is uplifted. So this is what convergence is. In the other case, we have convergence in the topper levels. That is what we see the convergence at the ground. We have it in the topper levels. So convergence gives rise to subsidence. Convergence in upper levels gives rise to subsidence. And once the wind falls to the surface, the exact opposite of convergence happens. That is divergence. In divergence also there is deflection of wind. So wind doesn't travel in straight paths because of Coriolis force. So if you take the upliftment process is associated with cyclonic conditions. So cyclonic conditions are nothing but a cloud formation, that is cumulonimbus cloud formation and subsequent rains. So when there is moisture in air and when this air is moving upwards, there is condensation of water droplets which give rise to clouds, and when condensation becomes severe, then it falls to the ground in the form of rain. So this is nothing but cyclonic condition. It is also called as a condition which is associated with instability. So upward movement is associated with convergence at the bottom level, and this is associated with instability in the atmosphere. So this area at the surface is called as a low pressure center. And in the other case, there is anticyclonic condition where a parcel of air falls to the ground, that is there is subsidence. This subsidence is associated with a clear skies, that is there is no formation of clouds. This is because when air is uplifted, it loses all the moisture in the form of cloud formation and rains. Hence, when this air moves along the upper levels of troposphere, it is completely devoid of moisture. And hence, when this air falls to the ground, this has very little moisture, and hence, when there is no moisture, there is no cloud formation, and hence the skies appear very clear. And when this falls to the ground, it simply diverges at the surface without any rains or any unstable conditions. So it is a condition which is associated with complete stability, and the movement of air at the bottom surfaces or at the low levels of troposphere is divergence. So this is the difference between cyclonic condition and anticyclonic condition. So cyclonic condition is associated with convergence in the bottom layers, which is called as low pressure center. Anticyclonic condition is associated with a divergence or a high pressure center at the surface of the earth. So when we talk about horizontal movement or advectional movement, it is mainly due to pressure differences. We can see this is a high pressure center, this is a low pressure center. So there is a difference between pressures in these two centers. Hence, wind flows from high pressure centers towards low pressure centers. So this is horizontal movement, that is the wind moves along the surface of the earth, and it is called as horizontal movement. But if you look at both horizontal and vertical movement, the major driving force is differences in temperature. When there is difference in temperature, there is difference in pressures. So this difference in pressures give rise to movements of air. So this is how it looks in a three-dimensional view. We can see this is high pressure center at the bottom where there is divergence, and here it is convergence. We have a low pressure center. So this swirling motion is due to Coriolis effect. So wind doesn't rush in a straight paths. Instead, it takes a curvy paths. This is because of Coriolis force. So what is Coriolis force? Coriolis force is an inertial force or an apparent force. Apparent force simply means that it appears as if there is force acting on a body. In real terms, there is no such force. It is only what appears to our eye. And when we say it is an inertial force, it simply means that the force acting on the body is due to its virtue of motion or inertial position. That is, first we need to see what is Newton's first law to understand this. According to Newton's first law, a body stays in its state of motion unless there is an external force added to the body. For example, if a body is at rest, it will be in rest for a long time when there is no application of external force, and this state of motion continues as long as there is no external force which is there to accelerate or decelerate a body. So if you take a body which is moving, so it will be moving unless there is a force which is there to stop it or to accelerate it. So its movement or its velocity doesn't change. Same when there is a body at rest, it continues to stay in rest unless there is some force which is acting on the body to change its state of motion. So for a better understanding, we just need to look at these animations. They have very clear explanation. But before that, let us see about the direction or deflection of a moving body in both southern and northern hemispheres. So wind or any other substance which moves over a very long distances deflect towards its right in northern hemisphere and towards its left in the southern hemisphere. So if a person is standing and is facing towards north, then deflection would appear right. So if a person is standing at the equator and is facing towards south pole, then the deflection would appear to be in the left direction. So this Coriolis force is important in understanding the circulating motion of cyclones at the low pressure centers or high pressure centers. That is, both divergence and convergence have a kind of spiraling motion. This is because of Coriolis force, as you can see in this figure. So Coriolis force doesn't act on a body which is not rotating. So the most important part of Coriolis force is the rotation of the major body. So without rotation, there is no Coriolis force. Let us take these two pictures for better understanding. So in this picture, we can see in the first picture how a body is thrown which is traveling a straight path, that is, its path doesn't change, it travels in its own path. But if we trace a path on the object that is rotating, we'll observe that there is a curvy path which appears to be the path of the object. So this is nothing but Coriolis force. It is an apparent force, what appears to the eye, but in reality there is no such force acting on a body. It is only just a path which appears to be curvy because of rotating motion of this object. So even the other objects explains this clearly. We can see this is a circular disc, two-dimensional one, and when an object is thrown from the center, we can see it travels its own path, but the intended destination has already shifted by certain distance, and as a result this movement doesn't appear to be a straight line. Instead there is a deflection like thing which appears for us that the path of the body is a curvy one, not a straight one. So this is nothing but an apparent force, not an actual force. So if you look at this figure, you will have much better understanding. This figure very clearly explains how a body moving from north pole towards the equator appears to be deflecting. If you see, Earth is rotating and Earth has certain angular momentum or angular velocity which is greater at the equator. Hence equator is moving at a greater speeds. So imagine that a body is thrown from this point, that is the north pole, and there is an intended destination which is at this point, so which is moving along this black line. So this should have been the actual path of the object, but you can see as the Earth is rotating, when we throw an object, this object travels in its own path, that is straight line, but the movement for a person standing on Earth appears to be deflecting. We can see the blue line indicates the actual movement of the object, which is a straight line, but due to rotation of Earth, this is what the deflection or movement appears to be. We can see this curvy path, that is the red one. This is how the path of an object appears to be when we see from Earth. So this is nothing but apparent force, that is, it is not happening in real terms. It is only due to rotation of Earth. It appears as if the body is deflecting. Likewise, when we throw an object from equator, the same thing will happen, but at equator there is different kind of force acting. At equator we have a greater centripetal force, that is outward throwing force which is acting along the tangent of the Earth's equator, and we know that Earth has angular momentum or angular velocity which is quite great at the equator compared to at poles. At poles angular momentum is completely zero. There is only spin, but there is no angular momentum, that is the body doesn't rotate at the poles. So at the poles there is no rotation, there is only spinning. Whereas when we consider at the equator, there is rotation as well as the axis spins on its own orientation or inclination. So if we take an object which is moving from equator, it would have a certain velocity, initial velocity, which is equal to Earth's rotational velocity. And hence when this object is thrown from the equator, it usually follows its own path, that is, it has initial velocity, and it will be moving at a certain speed along with the Earth's equator. And due to the rotating effect, this path appears not as a straight line, but it appears as if it is deflecting towards right. So this is a matter of imagination. So if you can imagine this thing, it's easy. But all the scientific stuff is not important for our exam. It is only for understanding purpose. But there are two important points which you need to remember. One is the Coriolis force at the equator is 0. That is, a body doesn't deflect when it is at the equator, but once it leaves equator, the body starts deflecting. And the deflection is not so high, about 5 degrees north and south of equator, and hence there are no tropical cyclones in this zone. Whereas when we cross after 5 to 10 degrees, we see intense tropical cyclones happening along around 20 to 30 degrees north and south latitudes. So tropical cyclones are greatly affected by Coriolis force. And the Coriolis force at the poles is maximum, that is, it is taken as 1, both at south pole and north pole. So this is a very important point. Coriolis force at the equator is 0 and Coriolis force at the poles is 1. And we know that we have seen that in the northern hemisphere it deflects to the left, right. In the southern hemisphere it deflects to the left. So this is true not only on a simple objects, even it's true on the movement of waters. When studying ocean currents, we'll see how ocean currents are affected by Coriolis force. And imagine that a jet plane is moving on in the atmosphere. Even the path of jet plane seems to be deflecting because of Coriolis force. And Coriolis force depends on two factors. One is the velocity of the object. When the velocity of object is greater, the deflective path we see is also greater. So when an object travels very slow, even Coriolis force is not usually observed. But when an object travels is at much faster speeds, then the Coriolis deflection, that is, deflection becomes much intense. So imagine a body is traveling at certain speed. Its deflection would be certainly comparatively low. But if a body travels at much greater speed, then the deflection would be much higher. So this is how Coriolis force depends on speed. Actually, it's an apparent path. We need not worry about how this thing happens. And these are important properties of Coriolis force. So this figure gives you a very good explanation. If you have found the other ones hard, you can see the movement of the object is straight line, so it doesn't deflect, but the apparent path due to rotation appears as if the object is deflecting along this blue line. So now let us look at various pressure belts, and also we'll see at winds originating from these pressure belts and how these pressure belts are formed. So we have seen that there are total 7 pressure belts, 1 equatorial, and we have 2 each subtropical, subpolar and polar highs. First, let us take a look at equatorial low pressure belt, which is also called as Doldrums because of the calm nature which is observed along this equatorial low pressure belt. So what happens along equatorial low pressure belts? We have seen that this is equator, and let us consider that these are poles and this is sun. The sun's intensity is quite greater at the equator, hence the amount of heat received at the equator is highest. Due to great amount of heat received at the equator, the air at the equator is uplifted. We have seen in upliftment how upliftment happens. And when this air is uplifted, there is a negative pressure which is created at the bottom layers, and hence winds from the surrounding regions come and occupy this layer. And during this movement of winds just don't come and go this way. Instead, they have a curvy path because of Coriolis force. And when these winds are uplifted, they usually leave a gap between them where there is a calm condition existing. So if you see, there are winds that are coming. Assume that this is equator and this is 5 degrees north and this is 5 degrees south. So when winds touches these 5 degrees north and south latitudes, due to negative pressure, they start uplifting or moving towards the upper layers, and hence there is no horizontal wind between these two latitudes, that is 5 degrees north and south, and hence this whole region, that is what we can see in this blue line, is within blue lines, is nothing but a region with very slow or very ineffective horizontal winds. As a result, it remains calm for a long time, hence it is called as doldrums. So this is about equatorial low pressure belt. So there is upliftment at the equatorial low pressure belt. So, and we have also seen that when there is upliftment, there is cloud formation because of moisture content, and also there is huge amount of ocean along the equator. Hence, there is a lot of moisture available for the cloud formation and subsequent thunderstorms. So when there is cloud formation, we have seen that there is cumulonimbus cloud formation due to accumulation of moisture, and this cloud formation gives rise to huge amount of torrential rains, or rains which last for only few minutes, but they are very heavy. So this is the kind of climate which we see at equator. All the regions lying along the equator, mostly if they are very near to the oceans, then they receive huge amount of rainfall. And if the region is very interior of at the very interior of continent, that is due to continentality, even if it's on the equatorial low pressure belt, it may not receive rains because all the rain is exhausted at the coast or in the outer landforms. When the air reaches interior, it is completely devoid of moisture because of saturation before reaching a certain place. So we'll understand this later, but just an explanation. So if you see, this is zone of convergence of trade winds. Trade winds are the winds which are blowing from subtropical high pressure zone. So we have surrounding the equatorial low pressure zone two high pressure zones. From there, the wind is blowing towards this negative pressure zone, and this wind, we can see, it is deflecting towards its left because its deflection is towards its right in the northern hemisphere and towards its left in the southern hemisphere. And hence these winds travel from east to west, and this east-west movement gives them the name easterlies. So they are also called as trade winds and also easterlies. So these easterlies converge at equatorial low pressure and they are uplifted and they cause huge amount of rain at the equator. So this is what happens. And once the air reaches the upper levels, they are completely moistureless because of all the moisture is lost in the form of cloud formation and rains. Hence this air which is reaching the upper layers is completely dry and warm. And as it moves away, from this region, that is when there is divergence in the upper layers because of accumulation of this dry air, it falls at a certain regions on back to the earth. This is because the air gets cold and denser. As a result, it falls back to the earth, and this zone where the air falls is called as subtropical high pressure zone. So what we see here, both the subtropical high pressure zones are the ones where there is subsidence of air. So we'll see that later. So these are extremely low pressure regions, that is equatorial low is an extremely low pressure region with calm conditions. Calm condition simply means that there is no horizontal movement of air, but it doesn't mean that there is no rains. There is abundant amount of rains in this region. Surface winds are generally absent, and it is called as doldrums because of extremely calm air. So trade winds are nothing but winds that are blowing from the surrounding high pressure systems into the equatorial low. So they occur between 30 degrees north and south latitudes. So usually high pressure belt is situated around 30 to 25 degrees north and south. So the trade winds blow between high pressure and equatorial low. And there are two trade winds. One is coming from the northern part, other one coming from the southern part. So they are both easterlies. So that is all about trade winds.